Hello, this is Fredrik from Tektronix. I wish you wonderful holidays. I hope this video will be published today. And for you that have following me, I'm so sorry I haven't been able to publish more videos. I will be better in Q1. Today I'm going to focus a little bit about scopes, especially I'm going to play around with the MSO6 and talk a little bit boxcar. But first of all, what kind of scopes do we have and why do I select? So we have the 3 and the 4 series, which is basically the same user interface. I'm not going to focus on them today, probably in another video. We have the 5, I think I did a video on the 5, the 8 channel version, but also have a low profile. And then we have the MSO6, which I'm sitting next to me right now, and that also have a low profile version. But I like this one. It's one of the best mid-range scope and goes up to 8 gig. And as you know, you can easily upgrade them in field. So you can start with 1 and just field upgrade them to 8. So one of the things I want to talk about today is a little bit about philosophy about boxcar. Some of you customers have met and I can say a boxcar blah blah blah, boxcar blah blah blah, but what we try to do is give you 4 big updates per year, once per quarter, and they could be things that is for free that people are asked for, or it could be specific to something that you have to pay for. So I will cover a little bit of those today, and I will try to remember which costs money and which is for free. So I show you one of the features that was added lately, the latest boxcar. I'm not sure what I'm doing now. I should be in the user preferences. In the user preferences under others, and you can check if you have the latest. If this doesn't visible for you, you don't have the latest, visit www.tech.com and search for your software. So this is selectable font size, because in my age I have hard to see in the distance. So you can go from 12 today, which is the lowest one, but if I look at the scope I cannot see anything. And for the purpose of the video I will go for the biggest one. I think it's easy for everybody just to read what's in here. That's one of the cool stuff. The other stuff that has been in there from the beginning, but I will tell you again, is you can invert the screen, and you can also set up how you want the auto set to work. I think this is making life easier, especially for me. But don't do anything with acquisition horizontal. Next part I will tell you is that about spectrum view. So spectrum view, let's do an auto set. Spectrum view is a function where we kind of divert the signals into 2 paths. And one path goes to the normal scope, and one path goes to a digital down converter. And the beauty of doing this is that we can correlate RF and time domain. Secondly, if you ever work with FFT, we can kind of skip, sample rate skip, and we can control that. So I've done a video of this one before. It's a 40 megahertz clock with some issues. I will do the same kind of test now using the function called spectrum view. So to enable that one, you need to think, okay, I need to route something into spectrum view. Do it in the channel. So in the channel there's a tab called spectrum view, and this is now what I'm showing you. Most of that is for free, and I tell you most because the span on my unit is 2 gig, and that's an option. I think the standard is 1.25. So I go into the spectrum view and I will put down the center frequency of my clock, which is 40 megahertz, and I will reduce the span to something that is useful, maybe like 1 meg, 500k. And you can see the resolution bandwidth here is 200 hertz, but I didn't change anything in the time domain. And if you look at this one, you can see from time to time it bumps up. So maybe I should have a max hold. I go in under here, I go into the spectrum view, and I have a max hold. And the max hold will hopefully capture this elusive event that happens from time to time. And if it doesn't, there it did. So this is how this glitch looks like from a frequency domain perspective. If you're not used to this one, I will also go up in here. So a 200 hertz resolution bandwidth is quite long. It's quite long. So what I will do now is I will try to trigger on this one, and I've done it so many times. It's roughly, it's an edge. We go for pulse width. I think it's around 11 nano. And we should have set it's the normal trigger. So every trigger. And now I can actually, this you can zoom if you have the pinch. So I will go up a little bit in resolution bandwidth. And we go out a little bit in time. So you can see it's actually fluently just working fine. So as soon as I have one here, right now underneath here I have something where I can look at the spectrum. I can drag it. So you can see what happens, especially around that point where my PLL is dropping. You can see the FFT. That's one function you can do. The other function, I will go back and just do an edge triggering again, and I will just run it. It's a simple measurement of frequency. So we will go in here again. I think this is good enough. And now we will measure frequency. So I will measure frequency on this one. I'll measure frequency and add this. And I will have a time trend. Can do that. No, we don't do that. And the one new feature they have is you can take this one, and if you pull it rapidly down, it will disappear. So we have frequency, and we can take show statistics, min and max, and delta. And then we, under this one, cost money. Under the spectrum view here, we have a tab called frequency versus time. So we'll add that as well. And it's down below here, and we just need to scale this a little bit so you get something. And I stop, and I measure this one. I just measure peak to peak, and that's 753 hertz. So you see the difference in measurement here. So in one case we have 753 hertz, which is how stable the clock is when it's stable, and the other one is telling us 77 kilohertz. Yeah, big difference. The nice thing is that you have one of those per channel. So if I look at channel number 2 now, which I have connected to another device, put this at 50 ohm, and we just run this once. I need to, because of my size, I will remove this one. Yeah, we're good here. And then on the spectrum, I have 2 now, and it says lock center frequency across all channels. We don't want to do that. So channel 2, I want this to be around 2.4 gig. 4 gig. Can I get gig? Enter. So if you do now, and I now put this one on, spectrum view on, and run. Now I have one running at, we can actually have a little bit more span here. I think that is going to be useful. Like 5 meg. You have one here running, oops, and you can see that what's going on. Actually going to go that a little bit further than 2.4. I'm going to go to, let's say 20, maybe 50. We can do 50. And now you can see that we're hopping here. You probably don't see that the good, but one is at 40 megahertz. The second channel number show is 2.4 gig, and this is just working. Of course, there's people saying that, oh, we need to, you should increase the little bit. Fine. And if I now do the same thing as I did in the previous one, have a time trend over this one, spectrum view, and have a frequency versus time, a little bit longer time frame, and preview. I don't know if you see that very clear now, but I can actually see the frequency hop I have down here. And of course, this one, another cool feature, if you double click here, you can overlay them. So they have 2.4. Anyway, everything just works fluently. So you can see that there's a frequency hop here, and of course I can do as measure. I can measure the peak to peak. So here I can see the peak to peak. It's 9.7 megahertz. So this one is hopping. So I hope you like this very short video. A lot of information. The thing is, what I like about this, there's 2 ways of saving stuff. Now, if you've been around me, you know that I always promote what I call the session. So you can save a session, and you can also save as a report. As I'm running Linux now, you don't have the USB disk, so I prepared one for you. So if you do a report, this is how it's going to look like. Which model, serial number, Tekscope version, calibration pass, what kind of probes and serial number do you have. So this is a differential probe, this is a logic probe, some measurement, frequency, measurement peak to peak, so you can see the deviation. So in this case I did the kind of same thing. Look at the time domain and look at this, and just the beauty of this one is that the peak to peak on this frequency when I measure from the time domain is 2.36 megahertz, but looking at the peak to peak of frequency is 256 hertz, so it's a big difference. And on the other side, if I do a default setup now, this is default setup. If I now recall the session I did, which was the last session, I have many session, this one, and I recall it, what I get is not only the setup, but actually get the real data, and I can continue doing measurement. So a lot of customers find this function really neat if you work with projects, because you know how it looks like before you go that. So again, very short, normal video from me. I will try to do a more in-depth video soon. I'm not sure, I'm going vacation soon. The last thing I would like to say, if you have any ideas or feedback or something you want to do, or features you're missing, please just put a note on the YouTube field, and I will try to address that directly to the product line. I hope you enjoyed this small video, because it's just working really good, this scope. I love it. Thank you. Have a great holiday.